Okay, so now we're going to talk about compressors. And you will be required as part of the next lab to go and tell me what style of compressor we have in our lab. So that will be a requirement. Make sure you can recognize it when you see it. So page 215, section 11.4, we dive into air compressors. And the book kind of says this thing like, here's some math, here's some theories on air compressor. Basically, compressors are different than hydraulic pumps because we are creating energy by taking air and squishing it down. Water is not very compressible. You kind of compress it a tiny, tiny bit, but you really can't. If you squish down on water, it doesn't go anywhere. Same thing for hydraulic fluid. You can slightly increase its pressure by pushing down on it, but it's not going to be compressible. Whereas air, the more I squish down on it, the smaller it gets. The more I squish down on it, the smaller it gets until I can get a tiny little pocket of air. If I squish down hard enough and it doesn't squeeze through my fingers, that air becomes super high pressure. And the book tries to go through that process by showing you a cylinder head pushing down onto a cylinder and showing you how the pressure increases based on the volume decreasing. All right, so that's all you really need to know. The idea is you can squish air, you can't squish hydraulic fluid or water much. The cool thing about air is I can squish it and store it. Hydraulic pumps only give me pressure while they're running. As soon as I stop, they effectively lose their pressure, Whereas air, I can run that compressor, fill up a tank of pressurized air, and now I can use that pressurized air like a battery. It's like a stored energy source. And if anybody has worked in a shop, you know that you can fill a little tank with pressurized air, then walk out to a vehicle far away from your compressor and use that pressurized air to fill the tires in that vehicle. That air is then available for those tires. So that tank is storage. The hydraulic stuff, you can't really store the energy. I will mention a couple things in this. The book is pretty good at describing different techniques. Corrosion is a big deal in air systems. Corrosion is a very big deal. One main reason for that is when you compress air, normal air from the outside world, it has liquid in that air. Everybody has got humidity in their building. If you have a zero humidity environment, then you're probably really dry all the time. Most environments have some quantity of air that's got liquid in it. So that liquid, when you pressurize, you compress that air, has to go somewhere. It drops out of that pressurized air and becomes condensation. So liquid in your airlines is a common problem. And that's why we have filters and dryers in airlines. And you're going to learn about that a lot more in your fluid power class. You have to get rid of that water in your airline. And that water creates a big source of corrosion, which is why we mostly need to get rid of it. Now, the book also talks about how there are different compressors that follow the same rules as the hydraulic pumps we talked about earlier. You've got, gear, vane, and axial piston and radial piston style compressors. And that's true. However, most of your compressors out there, the less expensive common shop compressors, even very, very large shop compressors, have 2 cylinders and they're piston style compressors. So this is the most common right here. And figure 11-2 shows you a single cylinder compressor, and the most common, especially for smaller shop compressors, look like this. Hint, hint. Now, there are some fancier compressors out there, and figure 11-14 shows you a screw type compressor, which is different than these other compressors we talked about, these 3 other compressors we talked about in hydraulics. It basically is a big old screw that spins and pushes air based on the shape of that screw up against an outlet. And they also, just like most other compressors, fill an air tank. Compress the air into a tank, and then you can use it out of the tank. Now, I will mention something very, very important. That is the duty cycle of a compressor. If you buy a compressor that is designed to only run 10 minutes out of the hour, right? Or 15 minutes out of the hour, guess what happens when you run that compressor constantly? It overheats. It gets very hot. It starts smoking, and it could burn up and cause a fire alarm. So you want to be very careful when you select compressors to understand what their duty cycle is. These style compressors tend to be very loud. These screw type compressors tend to be very quiet, and they're much better for indoor applications, but they're also very expensive. So I guess that's all I'm going to talk about in terms of compressors. Let me pause this.